Hi, everyone, and welcome to our Tickborne Boot Camp. Today, we have Dr. Thomas Sult with us, and he's going to be talking about why only the 10% of our patients are getting kind of the chronic form of Lyme. So let me introduce you to Dr. Sult. Dr. Sult is a medical doctor from UCLA with over 30 years of clinical experience and a passion for holistic health and is dedicated to personal root cause medicine. Instead of focusing solely on the diagnosis, he seeks to understand why would you have this disease. This is a very different question and leads to very different opportunities. By getting to the root cause, we can elevate wellness to the point where illness cannot flourish. Outside of medicine, Dr. Salt enjoys hiking, backpacking, skiing, and mountaineering. He values quality time with his family and friends. He lives with his wife, Elizabeth, and her 3 sons, and has 2 adult sons with wonderful families and his soon to be 7 grandchildren. So Dr. Salt, we're so excited to have you here today to share your knowledge with us, and I will let you go ahead and take it away.
Well, thank you. So one of those, the most recent, the 6th grandson gave me a virus over the weekend. So I'm recovering from that. So if I sound like a 4-pack-a-day smoker, it's not true. It's the virus. So let's get into it here. And what am I talking about here? Well, it turns out that most people who get Lyme disease just fight it off on their own. You know, we think about Lyme disease and all of our patients are coming in, they're chronically ill and everything's terrible, but most people fight it off on their own. Only about 10% get the chronic form. And if it's true that most people fight it off, we really have to ask the question, what's unique and different about our patients? And if we can find their uniqueness, that is usually the key to their recovery. And that's what we're going to be looking for today. So, and that boils down to, is it really a chronic infection? Is it post-acute sequelae of infection? Or is it both? Find my right buttons here. So, first of all, you know, insights are born from wisdom. Wisdom is a prodigy of humility. Humility evolves from knowledge. And knowledge is earned through error. And I'm really good at error. So here we go. Who's at risk? Well, things that put you at risk for chronic Lyme, environmental issues. So toxins, mitochondrial dysfunction, microbiome dysfunction, and many of the things that other speakers during this boot camp are talking about. The severity of the initial infection or an insufficient initial immune response, presence of co-infections, you know, in northern Minnesota. So I live in central Minnesota, and I'm right on the dividing line of southern Minnesota, where 1/3 of the ticks carry Lyme, and northern Minnesota, where 2/3 of the ticks carry Lyme. And in northern Minnesota, 1/3 of the ticks carrying Lyme carry at least one more bug. So co-infections, very common. And then in addition to co-infections, there are various imitators, or things I call imitators anyway. And then there's genetic and epigenetic factors like cytokine balance and microRNA. And this was a new concept to me several years ago, I guess now. But you know, we all learned about messenger RNA. Well, microRNAs are different. They're actually regulatory molecules. And then toll-like receptors and many other things. And then your autonomic nervous system state is another big issue. So think about this. If you're in fight or flight, you're shunting blood away from your gut to go to your proximal muscles so that you can fight or run. Well, that suggests that you're going to be functionally malnourished because you're shunting blood away from the job of digesting and absorbing nutrients. It also turns out that 70% of your immune system is intimately associated with your gut. It's called the GALT, the gut-associated lymphoid tissue. And so you're shunting blood away from your immune system. Additionally, your liver is in that same splanchnic circulation as are your adrenals. So you're going to be, challenged in terms of detoxification, in terms of adrenal function. And the spleen's there too, so even more immune dysfunction. So, and how many of our patients today, because we live in this all yang all the time world, I think it's easier to count the number of patients we see who aren't in fight or flight these days. And certainly if you've been chronically ill for any amount of time at all, you're going to be worried and you're going to be in some level of fight or flight. So while fight or flight probably didn't make you sick, it may well be keeping you sick. And so limbic retraining ideas are going to be really important for these people who are chronically unwell. So why is chronic Lyme so darn hard to treat? Well, two big reasons. Stealth pathology. Stealth pathology are mechanisms that the bug uses to evade our immune system and evade antimicrobials. And we're going to talk about some specific mechanisms of stealth pathology. And the other one is this idea of post-acute sequelae. Now, this idea has been around for a long time. And there are many bugs that can display this idea of post-acute sequelae. Most recently, sorry, I have a mint in my mouth to prevent me from coughing. But most recently, it's COVID-19, right? We talk about post-acute sequelae of SARS-CoV-2, right? But many bugs display post-acute sequelae. And this is basically the body not appropriately organizing a resolution phase of illness. It results in autoinflammation. It can escalate to autoimmunity. Tissue damage can cause tissue inflammation, neuroinflammation, and the sequelae thereof. And then you can have a mix of both. You have both. And I guess this got out of, in this program, you can move slides really easily, which isn't so great. But another part of the risk, well, delayed diagnosis. Delayed diagnosis. So let's say you go to the doctor because you have an erythema migrans rash, a bullseye rash, a Lyme rash. And the doctor goes, oh, yeah, that looks like a Lyme rash. We better send off a Lyme test. Well, the rash becomes present between 3 days and 3 weeks. The lab becomes positive between 3 weeks and 6 weeks. So if you have a rash and it's too soon for the standard Western blot or the standard, 2-stage test to be positive, that simply because of that mismatched timing, your test may come back negative. And now you've got acute Lyme, something that should be hopefully easy to treat. But because it wasn't treated, because the lab came back negative, suddenly now it's allowed to disseminate and become much, much more difficult to treat. Another issue becomes immune response issues. So TH balance, TH1, TH2, TH17, all the THs. And then delay type hypersensitivity versus humoral. And it turns out that humoral responses, which is what we always measure, right? We measure IgG and IgM. Well, humoral responses are really important to prevent it from coming back. But they aren't really the thing that causes clearing of the disease. It is the delay type hypersensitivity reaction that happens that actually clears the disease. And it turns out that Lyme disease is particularly good at inhibiting a delayed type hypersensitivity reaction, and it's particularly good at prolonging an IgM reaction and inhibiting an IgG reaction. And then comorbidities. Well, all the usual suspects here, right? Metabolic syndrome and hypertension and all the things associated with metabolic syndrome, but also fibromyalgia and chronic fatigue syndrome and other autoimmunities are risk factors for long Lyme, chronic Lyme. And then environmental issues, so toxins, environmental toxins, mitochondrial dysfunction, microbiome dysfunction, and anything else one might find on the functional medicine matrix. So let's talk about the mechanisms of stealth pathology. So first of all, stealth pathology is the pathogen being able to evade detection by the immune system. And Lyme could do this, EBV and CMV and herpetic viruses, mycoplasma can do it, chlamydia pneumoniae, Bartonella, toxoplasma, even the flu can do this. Giardia can do this. Many bugs can do this. So the first mechanism that we'll talk about is antigenic variants. And this can be from genetic recombination, gene conversion, or phase variation. And what this basically means is, if you think about the bug as a leopard, the leopard can change its spots. When it changes its spots, it might not look like a leopard anymore to the immune system. The next issue is intracellular survival. These bugs can burrow in. They actually have proteins they make, one called adherin and the next one called porin. Adherin is sticky stuff that lets them stick to the cell. Porin actually allows them to make a pore through the our cell membranes and gain entry into the cell. As an example, these they've been demonstrated to grow in culture inside fibroblasts for weeks and weeks. Like 8 weeks was when they decided to throw the cultures away. We also know that they can gain entry into white blood cells, and they can use those white blood cells like Trojan horses to just cross the blood-brain barrier with impunity. They can also escape phagocytomes and manipulate the intracellular mechanisms or machinery to make the internal environment and make the cell signaling environment more conducive to their own survival. And that leads to them being able to suppress the immune response. They can manipulate immunomodulatory molecules. They can suppress certain cytokines, and they can activate others. And we'll talk about IL-10 in a minute, but they can suppress certain certain inflammatory cytokines, dampening the inflammatory response. And they can promote regulation of T cells, and we'll talk about that more in a minute. And then they can also cause programmed cell death in immune cells, leading to what we've all heard about in COVID-19 as an example, this T cell depletion syndrome. Well, Lyme can do that as well. And then they form biofilms, right? I like to think about biofilms as fruit cocktail jello, right? You got all the little pieces of fruit, and each fruit could be a different species of bacteria. And then they can elaborate the jello. So if they feel threatened, these bugs can just elaborate more jello, makes it harder for the immune system or the antibiotic to kind of diffuse in. But in addition, one bug's exhaust is another bug's fuel. So they're cooperating and making the entire colony healthier. And then if one particular bacteria can make something like penicillinase, as an example, it can elaborate that penicillinase like a cloud into the matrix, into the jello, and protect all of the bugs in the jello, whether they can make penicillinase or not. So these guys are smart, and they're collaborating and they're colluding against us. And by the way, biofilms by themselves are not pathogenic. They are just a normal way in which bacteria grow. So you can have probiotic bacteria that live in biofilm. And our job here is not really to eradicate biofilms, it's to move biofilms in the direction of a probiotic biofilm rather than a dysbiotic biofilm. And then they can evade the immune system. And they can do this in a bunch of ways. One way is called molecular mimicry. And think of molecular mimicry like wearing camouflage. Now, if you're a hunter and you're out in the woods, like people do, in most cities, if you hear gunfire, it's like, oh my gosh. But here, if I'm laying in bed early in the morning and I hear a bunch of gunfire, I think, oh, my neighbor Fred is probably duck hunting. A hunter out in the woods in full camo, kind of kneeled down next to a bush, it's really hard to see. But if you take that same guy and you put him in a school parking lot, suddenly he's really, really scary, right? So the camouflage is trying to look just a little bit like your surroundings. Well, if you're in a human body, you want to look a little bit like a human body. The problem with that is once you get seen, so now you're in the school parking lot, the immune system is going to start making activity against you. And some of that activity is likely going to be against spots of your camouflage that look just enough like you to attack you. So that's where this autoinflammation and autoimmunity come from. And then I said I was going to talk more about IL-10. So IL-10 is an anti-inflammatory cytokine, interleukin actually. And so these anti-inflammatory cytokines, the bug can induce the production of IL-10, and so it shields the systemic environment from the inflammatory signaling. So you might well have evidence of infection at the site of entry, at the beachhead, so to speak, but the IL-10 being elaborated shields the rest of the body, so the rest of the body doesn't even know you're being invaded. And then there's this idea of latency. So we have spirochetes, which are cell wall spiral-shaped bugs. But if the cell wall becomes threatened, either by the immune system or by an herb or by, say, amoxicillin, which is a cell wall active antibiotic, the spirochete can just shed its cell wall. And then now it's a cell wall deficient form, also called an L form, sometimes called a spiroplast. But these cell wall deficient forms, maybe they become under further attack. Maybe you change from amoxicillin to doxycycline. Well, doxycycline is going to attack the ribosome in the bacteria. By the way, it's also going to attack the ribosomes in your own mitochondria. And when it does that, the cell wall form, think of those as the grapes in our biofilm, they shrink down to become in our biofilm, in our fruit cocktail jello analogy, those grapes are going to shrink down to a raisin. And so now we've got these little raisins, and these little raisins are biologically very inactive, and we'll talk about that on a slide or two in a minute. But then we also have this idea of quorum sensing. So quorum sensing really means that these cysts hang around, just sort of sensing their environment. When they realize the coast is clear, they auto-resuscitate themselves, and they become cysts, become these cell wall deficient forms, which become spirochetes. And now we're back to baseline with infection. So these cyst forms and other forms can have these low replication rates. They can be as functionally dormant or quiescent. And this can form a reservoir because they are so immunologically resistant, they become a reservoir. And they can also hide in immunologically privileged sites, so places where you have a very poor blood supply. So think of all of those places, joints and synovium, and then I already mentioned they can live for long periods of time inside fibroblasts and white blood cells and all kinds of different tissues. And then they can also induce T regulatory cells. So T regulatory cells have a modulating effect on immune responses. And then they can also, we already talked about the signaling molecules, so they also can subvert the antigen presenting mechanisms, the major histocompatibility complexes. They can inhibit their expression, blocking antigen presentation pathways and downregulating stimulation of antigen production or antibody production. Well, okay, so that's how the infection survives long term and evades and avoids and becomes phenotypically resistant to antibiotics. So normally when we think about antibiotic resistance, we think about genotypic, and we're looking for, the acquired resistance due to gene sharing and so on. But these stealth pathology mechanisms are phenotypic antibiotic resistance. So now we're going to talk about mechanisms of post-acute sequelae. Well, what is post-acute sequelae? Well, the first mechanism is all the stealth pathology stuff. So a lot of authors kind of lump together chronic infection with post-acute sequelae, and I separate them. And I think there's stealth pathology mechanisms that allow for chronic infection. And then there are these post-acute sequelae infections. And so I've already talked about the stealth pathology and the persistent infection. So let's go on to talk about immune dysregulation. Well, ongoing infection leads to inflammation. And this inflammation can become self-perpetuating because of ongoing tissue damage. And even after all of the pathogen has been eradicated, you can still have this ongoing feed-forward loop, this dog chasing its tail of chronic inflammation. And because of those molecular mimicry mechanisms and other mechanisms that we talked about, those molecular mimicry defense mechanisms can actually end up becoming autoimmune to the patient. And then there's also this breakdown of tolerance. So we don't normally think about it, at least I never did until I started treating Lyme a bunch of years ago. But there's sort of two sides to the immune system. There's the defense side, right? That's the delayed type hypersensitivity, the cellular immunity, the humoral immunity, all of that defensive stuff. But there's this tolerance side as well. And the tolerance side is really why we're not allergic to every single thing, right? How come some people are allergic to grass and others aren't? How come, some people are allergic to foods and others aren't? Well, that's tolerance. And when you start to lose the ability to recognize self versus other, this is a big piece of the ongoing inflammatory cycles and the perpetuation of those cycles that results in this post-acute sequelae. And ongoing tissue damage, we talked about, and these, it's all tissue damage, right? So, why do you have ongoing joint pain and muscle pain and brain fog? Well, we talked about the bug getting into white blood cells, getting into the Trojan, using them as Trojan horses. Well, the central nervous system doesn't like having foreign materials in there, right? So not only do you have a foreign material, but that foreign material, meaning the spirochetes, are causing damage. And that tissue damage also ends up being inflammatory. That activates your microglia. That results in chronic inflammation and results in a whole bunch of neuropsychiatric and neuroinflammatory sequelae. So then all of that plus your Lyme test might be negative. But what about the 20 or so more Borrelia species that have been associated with Lyme-like symptoms that aren't Borrelia burgdorferi? What about co-infections? What about imitators? What about overlapping symptoms of all of that, plus your comorbidities, plus immunomodulation? So it becomes a very complicated picture. And then there's host genetic factors, right? There's genetic variability in your HLA and toll-like receptors and microRNA environment. There's single nucleotide polymorphisms of your inflammatory genes. There's toll-like receptor changes, and how well do you actually, how well, or in other words, could it be not enough recognition of these pathogen-associated molecular patterns, or maybe you're hypersensitive to these patterns? And then what about antecedents, triggers, and mediators that are unique to that particular patient? So let's talk about Joan. Joan is a 35-year-old woman who has an 8-year history of escalating fatigue, joint pains, muscle pains, brain fog, and increasing anxiety. So she really didn't start seeking treatment until about a year after her symptoms started, because at first she just thought it was her hectic lifestyle. But increasingly, she started to realize she was the proverbial frog sitting in the pan. And at some point, she turned around and realized, gee, I am just not functioning well. So she went to her primary care doctor with the complaints of some fatigue and body aches and anxiety. Well, he did a physical exam, which was normal. A CBC and a CMP and a TSH were normal. She was diagnosed with anxiety and given Buspar. So she returns to the clinic with little to no improvement. She cycled through several antidepressants with no improvement. Her symptoms escalate to the point where it's her body pain that's now recognized as primary, and she's sent to a rheumatologist. The examination at that point was essentially negative, and she was basically dismissed. Later, due to escalating brain fog and memory issues, she was sent to a neurologist. The neurologist didn't find any worrisome focal findings, but he sent her to for a neuropsych evaluation. The neuropsych evaluation suggested significant memory and intentional issues, executive function or dysfunction, visual spatial processing issues, word finding issues, some evidence of depression, anxiety, irritability, and mood swing, and then some coordination issues, and of course the fatigue. So she was diagnosed with dementia, and she had a very extensive workup, including an amyloid scan, which was negative. She was on multiple meds, none of them really helped. She basically gave up on conventional care and spent several years in the alternative medicine space. And then eventually she was seen by a chiropractor who suggested she might have Lyme disease. She said she didn't treat it, but she knew somebody who did and sent him to a local functional medicine doctor. So on her way to see the functional medicine doctor, she stopped by her primary care doctor and got a standard Lyme test, which was negative. So the functional medicine doctor evaluated her and saw that the test was negative, saw that she was feeling terrible and had tons and tons of symptoms, and explained to her that the Lyme test can be negative, but you can be positive, and she promptly referred her to me. So thank you for that. Don't you love it when you get the train wrecks? When I was a resident, I called up the OB, and she was in a room with a patient. So I told her receptionist, I said, well, listen, tell her I'm on the OB floor and we've got a train wreck up here and I need her to call me back. So about 10 minutes later, she calls me and she's laughing her head off. And she says, well, when you got off the phone, my receptionist bolted into the door and said, Dr. Arias, Dr. Sult has a train wreck on the floor. And apparently she thought I was serious about a train wreck, but that's just what we call people that are really sick, right? Anyway, I digress. So it turns out when I'm talking to her, she lives on a farm. Well, that's not that surprising. She's from Minnesota. She has 2 dogs, both of which have been diagnosed and successfully treated for Lyme disease. She has several neighbors who have had acute Lyme disease and treated successfully. They're part of the lucky 90%, right? She never even heard of chronic Lyme disease. She had absolutely no recollection of any kind of bullseye rash. She had no recollection of a tick bite. She had maybe a vague recollection of some kind of summer flu thing right around the time that her symptoms began, but hadn't really paid a lot of attention to it. So I explained this whole concept of chronic infection versus post-acute sequelae of infection and the possibility of both, and co-infections and imitators and the whole 9 yards. And, it's not just Borrelia burgdorferi anymore. The standard kit, I think I already said this, but the standard kit is really made to detect Borrelia burgdorferi. And if you have something else, even if it's a different strain, it may or may not detect it. There are now several species of Borrelia, something like 20 of them, that result in Lyme-like symptoms. There are several more that can result in tick-borne relapsing fever or just symptoms that vaguely resemble Lyme. And then there are co-infections, and then there are imitators. So let's talk for a minute about Lyme, about labs in general, and this idea of IgG versus IgM. So we generally see a clear distinction between IgG and IgM in most infections. Basically, we're taught that IgM means you have an infection and IgG means you had an infection. And, this is conventional teaching. In chronic infection, you don't really have a chronic infection most of the time. What you have is a chronically recurring acute infection from an endogenous site. In other words, you get an acute infection and the immune system mostly treats it and puts it in a box, but maybe doesn't treat it completely. and then it leaks out. And now you have another episode of acute infection. So you're getting these surges of cellular immunity and IgM and IgG. And I already mentioned how Lyme disease is particularly good at suppressing the delayed type hypersensitivity and promoting the IgM and suppressing the IgG. And so you get this, I think of it like maybe you guys aren't old enough for this, but on the old stereos or these graphic equalizers where all these bars are going up and down all the time. I think about these IgGs and IgMs as sort of like that graphic equalizer, and they're just going up and down all the time. And so it becomes somewhat confusing. And the diagnosis of Lyme disease really becomes a clinical diagnosis and a diagnosis of exclusion. And this is the position of the International Lyme and Associated Disease Society, who has published clinical guidelines for the treatment of Lyme. Now, this is a group distinct from the Infectious Disease Society of America. And so they each have their treatment guidelines that are very different. ILADS, however, in their guidelines in an appendix sort of put a compare and contrast. So they explain why their recommendations are different. So if it's a diagnosis of exclusion and a clinical diagnosis, what do we need to look for? Well, we need to look for evidence of exposure. Now, evidence of exposure could be a tick bite. Well, she didn't have one. Could be a rash. She didn't have one. Could be just living where there's lots of Lyme. Well, her dogs had Lyme and her neighbors had Lyme. It could also be a lab test that maybe doesn't reach quite to the height of a CDC positivity, but maybe it reaches slightly below that to an alternative criteria of some kind, and we'll talk more about that. And then you need to have an appropriate history and physical exam. You need to have an appropriate clinical course, and then you need to rule out the usual suspects, right? So you got to make sure it's not chronic fatigue syndrome or fibromyalgia or, MS or ALS or any kind of other weird things. So there's a long differential for Lyme disease. And if you treat Lyme disease, you kind of need to get familiar with that. I probably should have put that a differential slide in here, but I didn't. So the Vibrant Tick-Borne panel, I have two, 1.0 and 2.0. 1.0 looks, and I just counted these by hand, so maybe somebody else has a better number, but when I just counted up all the pathogens on a 1.0, it's 26 of them. It's 26 pathogens you're looking for. And on the 2.0, they add another 15. So there's a ton of pathogens to really be looked for if you're looking at tick-borne disease in general. So what about our patient? Well, here's her Borrelia burgdorferi panel. This whole page is about Borrelia burgdorferi, and it's all green. Green is good. So her initial test from her primary care doctor, remember, was negative. Well, that's because it was negative for Borrelia burgdorferi. Now, there's a lot going on this panel, though, that I want to kind of talk about right after I cough. Excuse me. The CDC definition for Lyme disease is described in the preamble to this test, and you can read that. And then there's an alternative criteria established by Vibrant Lab, and their criteria for IgG is, the one of the top two or one of the bottom two, the whole cell sonicates, those WCSs. So either the ELSE1 or C6 peptide or B31 or 297 whole cell sonicate, plus two in the middle. And IgM is similar, but the criteria for the middle ones is a little bit different. Now, other labs have different ideas and other authorities have different ideas. So the bands that I think are the significant bands I put on the left here. So C6 peptide, as an example, just an IgM, C6 peptide all by itself is someplace in the 90% specific and sensitive for Lyme disease. So if this panel came back with just an IgM C6 peptide, that would raise my index of suspicion for Lyme disease dramatically. Now, again, going back to my idea of a leopard, if each one of these things is a spot on a leopard, the more of them that light up, the more likely it is to be a leopard, right? The more of these things that light up, the more likely it is to be Lyme. starting with just one of them, specific one, C6 peptide, being very significant, right? But what about outer surface protein A or outer surface protein B or outer surface protein C or whatever? The more of these you have, the more likely they are to be significant. Now, certain ones like 41, that's really the flagella. So any flagellated bacteria could be positive for 41. So this person does not appear clinically, biochemically on this test to have Borrelia burgdorferi. But look at this. Lyme disease, Borrelia afzellii, 2 IgM bands. Well, at the very least, that's evidence of exposure, isn't it? And this is a bug that can cause Lyme-like symptoms. Tick-borne relapsing fever, Borrelia hermsii, an IgM, but a really high IgM. So that's interesting. That's piquing my interest. And then this column over here, I call these guys the usual suspects. Californiensis. Used to be a TV show called Californication. She's been Californicated, I guess. And sorry about that. And I'm from California originally. And then rickettsial disease, an IgM positive there. So some promiscuous tick has infected her, right? It appears. So imperfect action is better than perfect inaction. It appears she has tick-borne illness. Why do I say that? Well, she's seen by a whole bunch of really smart conventional doctors who really didn't help her, right? And she's got this evidence of tick-borne disease, and weird symptoms plus evidence of tick-borne disease generally equals tick-borne disease. That's an oversimplification, but it's an idea. So now the next question is not how do we treat it? To me, the next question is why would she have it? Because remember, only 10% of people who get Lyme disease go on to get the long form. And we went through all these sort of risk factors for it. So why? What's unique and different about her? So I feel that one of the very best ways to get to the why question is with the total toxic burden and organic acid test. This is a bundle through Vibrant. And I think it's currently $600 for this bundle. I use them all day, every day, like candy. I really like this test. But I have a certain bias, and my bias is that almost all the illnesses of modern man are because of the Industrial Revolution. And what did the Industrial Revolution do to us? Well, certainly it escalated toxins, right? But it also caused social isolation. We went from multi-generational homes to nuclear homes. Well, what did that do? Well, it increased adverse childhood experiences because no longer when a frustrated dad comes home, no longer is grandma or grandpa there to kind of say, hey, you know what, let me take the kids for a while. So now what happens? Domestic abuse, all these things happen. The other thing is the evolution of electronics. We went from, one telephone and having to share, and one TV and having to share. Well, we went from storytelling as a family in the living room after dinner to a television. And then we went to everybody having their own television, right? Everybody having their own phone. And even in cars, we used to have to play bingo, or we used to have to play I Spy as we drove down the road. And then we got a screen, and now every kid in the car has their own screen. So progressive isolation. Well, we know that adverse childhood events and isolation are huge contributors to illness. And we know that toxins are huge contributors to illness. So let's explore this idea. This is just the summary page for the high findings on her total toxic burden. There's a little key up here. So this little biohazard thing here that suggests mycotoxins. These gears suggest heavy metals, and the little factory here is environmental toxins. Let me get another cough drop going here quick. Excuse me. So she has 4 high mycotoxins. Now, in this case, high means greater than 95th percentile. Shows she's walking around with aflatoxin G2. She has more of that than 95% of people walking around. Same with all of these things, right? Lead. Lead's probably not good for you. Even the EPA agrees that there is no safe lead. There's no safe level of lead, and yet there's a permissible amount, even though that permissible amount is known to cause IQ changes. Palladium, and then all of these industrial pollutants. So she got 5 POPs. So this 11 in total, and that's just the highs. She's got 13 more at 75th percentile, 6 more mycotoxins, and 7 more persistent organic pollutants. I don't know about you, but I'm thinking we should investigate her building where she lives. She's got a lot of mycotoxins. Now, if you read about this, some of these will talk about how these mycotoxins can come from food. They can, but in the United States, most food is pretty well taken care of. I mean, certainly that's not 100% true comment, is it? But pretty well taken care of. And most people dealing with mycotoxins believe that most of it comes from wet buildings. So I ask people, do you live in? Do you work in? Do you play in? Do you pray in? Or do you educate in a building that may have water damage, high humidity, mustiness, or mold growth, right? It's not just their home. It's any place they go regularly. Then we did an organic acid profile. And again, this is just the summary. There are hundreds of analytes on these 2 panels. But this summary panel here tells me, if you page through it, it tells you, right? I look at a lot of these, so I know what these mean. But if you page through it, it says, energy production, carbohydrates. And if they're red, well, it probably means they're not burning carbohydrates well, right? So she's not burning carbohydrates well. She's not burning fats well. And her Krebs cycle intermediates are abnormal. If you remember, citric acid and isocitrate and alpha-ketoglutarate and succinate and all that whole circle, right? So, and then these markers down here suggest dysbiosis, specifically yeast and fungal overgrowth and bacterial overgrowth. So what about treatment strategies for this patient? Well, the most effective way to do it is to do it. So let's do it. And we talked about that. So she's got mitochondrial dysfunction. She's got dysbiosis. She's got toxins. She's got mycotoxins, toxic metals, and persistent organic pollutants. And then she's got probably Borrelia absiliae is the main bug, but she may have Hermsii and she may have this rickettsia stuff. So in general, I want to look at the functional medicine matrix. I want to look for antecedents, triggers, and mediators. I want to look at the modifiable lifestyle factors. And I want to address adverse childhood experiences and even adverse adult experiences. So diet. I chose this particular diet. There's many possible therapeutic diets that would be completely reasonable, but I chose a plant-forward ketogenic diet. Most people think that a good ketogenic diet is a bunless double bacon cheeseburger all the time. And that's definitely a ketogenic diet. Just may not be, in my opinion, the healthiest ketogenic diet. So a plant-forward ketogenic diet is anti-inflammatory. It's antimicrobiome, or it's a microbiome reset. It's very good at stressing the tick-borne bugs because they tend to be fastidious. They need a lot of sugar to grow in culture. And we're going to take their sugar away with a ketogenic diet. It's neuroprotective and it supports mitochondrial function. Sorry about that. All right. So that's the diet. I'm going to support the mitochondria. I'm going to use a broad spectrum antioxidant. I use something called dynamic greens. Each little scoop is the equivalent to 20 servings of fruits and vegetables from a phytonutrient and antioxidant point of view. I'm going to use turmeric Turmeric is traditional Indian herb that is anti-inflammatory. If you extract from turmeric curcumin, and then you extract from curcumin this stuff I call curcuphilic, that is a 400 times more bioavailable curcuminoid, so it gets systemic. And then fish oil, 3,000 milligrams of the EPA plus DHA component. And then the usual suspects for mitochondrial support: coenzyme Q10, lipoic acid, PQQ, ribo-ATP, those kinds of things. And then address the dysbiosis. Well, the dynamic greens has, I don't think I mentioned this, but it also has a prebiotic effect. I'm going to add some prebiotic fiber. I'm going to inhibit the bad guys with serum-derived bovine immune globulins. I often use an elimination diet, and you put an elimination diet as a dairy-free diet. So it's kind of hard to use colostrum on a dairy-free diet, even though its immunogenicity is low. They look at it and they go, "Doc, you put me on this dairy-free diet and you're giving me this dairy stuff. What's wrong with you?" So I kind of just settled on using serum-derived bovine immune globulin. And then I usually use more prebiotics than probiotics, but if I do use probiotics, I like to say I use Sagan doses. Carl Sagan was famous for saying billions and billions of stars. So I like to use billions and billions of probiotics. And then toxins. The first thing you do when you're trying to address toxin is minimize the exposure. Well, the Environmental Working Group is a great resource. EWG.org. They have the Clean 15 and the Dirty Dozen foods. So the Clean 15 are foods that are low enough pesticide residue that you can eat them conventionally. And then the Dirty Dozen are things that you either shouldn't eat or you should eat organic. They have clean personal care product recommendations. They have clean cosmetic recommendations, home care recommendations. We're going to do an ERMI test on the house because of the many mycotoxins. We're going to send her a DIY mold inspection handout if she wants to do it, or she can hire a professional. And we're going to start cleaning the indoor air. We're going to over HEPA filter. We're going to double. If she has a 200 square foot room, we're going to put enough HEPA filters in there for a 400 square foot area. We're going to get her mechanical room where her furnace and stuff like that is down to about 30% humidity. The rest of the house to about 40%. That's going to inhibit mold growth while we're sucking up the spores with the HEPA filters until we get true remediation done. And then what's the next step for detox? Well, we're going to optimize excretion. Well, that's the 5R program, the dysbiosis plan, the remove, replace, reinoculate, repair, rebalance. We're going to optimize phase 1 and phase 2, and some people talk about phase 3 and 4 detox. We're going to optimize mobilization of toxins with a high-fat diet. If you have a bunch of water-soluble toxins, you just drink a bunch of water. Speaking of that, and you would flush out those water compartments. But most of these are fat-soluble toxins, so we have to increase fat intake to flush out the fat compartments. That the fat is going to mobilize the toxins, bring them to your liver, process through phase 1 and phase 2 detox, put it into bile, inject it in your small intestine. And then if you don't have a binder sitting there to grab onto them, all of that detox is going to be taken apart and you're going to reabsorb that toxin. So you need tox binders. Now we're going to kill the bugs. We're going to do that last. Not last, but I mean, that's the last thing I'm thinking about. We're going to do it all at the same time, but we're going to do it now, not first, because people get thinking, oh, I'm just going to kill the bugs and I'm going to be good. No, we got to make your body more resilient by getting rid of these toxins. I like to use Biocidin. I like to use Stevia. Stevia was shown at New Haven to be better than Doxy in a in vitro study. At Johns Hopkins, cryptolepis was better than Doxy. Again, on an in vitro. And then Phytocidal is 4 more herbs. And so the question is, how long is it going to take me to get better? Well, I ask people 0 to 10, with 10 being great. And I throw in the word effortless. So perfect, vibrant, effortless health. Because people will say, well, I guess I'm a 10 because I get everything done because I drag myself through the day. Well, that's not effortless. So what is it if it's effortless? Well, okay, I'm something less than 10. So she said a 3, and I said, okay, well, in the first 1 to 3 months, expect to be herxing, Juris-Herxheimer reaction. I explained what that is. And we're just going to stir the pot because we're going to change your diet. We're going to have you on all these supplements. And as you know, people get sick from supplements sometimes. So we're just going to be stirring the pot for the first couple of months. And then I expect you to get better by 1 every 3 months. So that means, something like 21 months plus the time when you were herxing. So 3 months go by and she's feeling kind of good. And she has a lift of her brain fog and her body pain is a little bit less. And she says, okay, I think I'm a 4 out of 10. 6 months later, she's able to do more, feel better, less moody, brain is back. She can find most of her words. It's less embarrassing to talk to people, and she can walk without looking like she's 80. Those are her words. And she says, I'm probably a 6 out of 10. So great. She made a pretty decent leap there. So 9 months later, well, I'm getting better and I'm frustrated because I can see what needs to be done and I can't do it. And this is really common. When they get up above 6, they start to feel like, gee, I could almost live my life, but I can't. It's very frustrating. And you need to be talking about this stuff. If you're not letting people know, hey, this is going to be a 2-year battle, or whatever the number is that you calculate out for them, and you keep reminding of that every time, they're going to get lost to follow-up because they're going to say, hey, I've been seeing this jerk for 9 months. He hasn't helped me. So you got to keep bringing it up. 12 months in, I feel like I've stalled out. I'm still a 7 out of 10. And it turns out she's gotten kind of lax on her diet. She's not really checking her ketones anymore. She ran out of detox stuff. She's more likely to forget taking her antimicrobial herbs. So we had a pep talk. And she got back on the wagon. 15 months in, hey, I'm back on track. I'm feeling better. Or maybe an 8. She's back on the full program. Now, 18 months in, I'll tell you that it's harder to get the last 2 to 3 out of 10 than it is to get the first 3. So Joan reports not very much better, maybe about 8.5. And it took another 6 months to really get to a 10. But in the meantime, at every visit, we're talking about her 8-year journey through illness and how it's been a slow, frustrating pace, but she's nonetheless getting better. So we followed up at 24 months. She's weaned off of all of her supplements. She has liberalized her diet to basically a healthy whole foods program. She's living her life basically without limits. Her husband, who's been very supportive during this whole journey, says that she's a new mom, she's a new wife, she's a new woman, and we have our Joan back. So that is Joan's journey. And I would love it if we had an opportunity to have some conversation.
Yes. Wonderful. Thank you so much, Dr. Sult, for that presentation. And I really love the way that you calculate this kind of expectation of the healing journey for our patients, because I do think we have to be so upfront with them about how long this journey is going to be. And we don't want to just say it'll be a year, right? For them to have something tangible of kind of some benchmarks to look for. So thank you very much for adding that in. I would always tell my patients it's about 1 to 2 months for every year that you were sick. But I like that yours is a little bit is much more precise with kind of this scale of how they're living that vibrant life. So thank you.
The other thing I say, which I think is also really important, and I'm sure you do as well, is it's not, we're just putting you on this program and it's done. Now, you don't show your hardest cases in a forum like this, right? But usually there's more finagling. So, I tell people that at every visit, I'm going to ask you, are you better? Are you worse? Or are you the same? And if you're not better, I'm going to be asking myself, what did I miss? What should I be thinking about? What additional tests do we need? How are we going to get you back on the path to wellness? And people really appreciate that. A lot of times they feel like, well, I went to the doctor and he gave me this pill and he's done with me. Well, I want to make it really clear to people that, no, I'm never done with you. There's always something else to be thinking about. As long as you're not well, we're going to be working on this. And as long as they feel like you have a plan, they're going to be happy.
Yeah, absolutely. Absolutely. Wonderful. Well, we will definitely open it up. If you guys have any questions for Dr. Sult, please put them in the chat. I will shuttle them over to the slide here and we can address it. We have a lot of people saying thank you, great presentation. So thank you so much, Dr. Sult. I think that it's great to see how this all applies in very complex cases. Okay. Okay, so we've got a question here. Any further comments on the benefit of stevia? If you want to comment there.
Well, so stevia was recognized in sort of a high throughput in vitro study at New Haven University by Dr. Seppi to be the most effective thing that they studied, including doxycycline and other antibiotics. It has been shown to have direct-cidal effects. It's been shown to have anti-biofilm effects. It's been shown to be effective in both the exponential growth phase and the stationary growth phase. And the only downside that I'm really aware of is that it is a kissing cousin to ragweed. And so for people with hay fever, it can be a big problem. Maybe you could be more specific about how it's being vilified. Maybe I'm just ignorant about that.
Okay. We'll wait for just a follow-up on that, but we'll take another question here too. We have a question. Oh, this would be good for you being in Minnesota with all those mosquitoes. What are your thoughts about contracting Lyme through other vectors other than ticks?
So, there's the party line, meaning the CDC party line, is that it's black-legged ticks or deer ticks, not even dog ticks or, wood ticks. Having said that, I know that there's a big controversy around that issue, and I don't know the answer. And now I do know, though, that there are many imitators. Powassan virus, tick-borne relapsing fever, or tick-borne encephalitis virus, and other things that can be transmitted by mosquito, for sure. Whether or not Lyme can or not, I mean, on some level, if you took a syringe and stuck it into somebody and then walked over to somebody else and stuck it into them, it seems like that could transmit it. So, maybe, but there's no compelling evidence in my mind that it's definitely transmitted by mosquitoes, but I know there are smart people who disagree and think that there's all kinds of evidence.
Okay, very good. With tick-borne testing, are you doing dried blood spot, blood draw? Do you have a preference one way or the other?
I do almost all dried blood spots because patients can do it at home. And statistically, they're functionally equivalent. So, every once in a while, I have a patient who says, well, I want a blood draw. I want to get a real test. And it's like, okay, I'll do the exact same test with blood draw.
Yeah, exactly.
But I don't think there's a big difference. I think it's perfectly fine either way.
Yeah. And the validation, from Vibrant standpoint, the validation is the same, blood draw or blood spot. So there you go. Yeah.
So,
do you have any comments on SOT treatment for patients?
Yeah, so I use SOT in my practice. So for those who don't know what SOT is, basically there's DNA, as we know, and that's turned into messenger RNA. And then the messenger RNA, of course, gets made into a protein. Well, SOT is essentially an antisense messenger RNA that attaches to the messenger RNA, so it can't go through the ribosome, can't make the protein, and the Borrelia or whatever bug we go after with SOT dies. And it's a hyperspecific treatment, meaning that it doesn't affect any other cell other than the very specific target you're going after. I've had mostly very good results with SOT, but I like to say I have a tertiary care functional medicine practice. Everybody I see First, they were seen by the local doc. They were seen by the regional specialist. They were probably, because I'm in Minnesota, they were seen at Mayo Clinic. They were seen by 5 or 6 holistic doctors. And then they got to me. And many of them have been treated for Lyme multiple times before they get to me. And those people are often extremely difficult to treat. And I go early to SOT with them because it's a novel treatment that they probably haven't had yet. And in those most difficult of the most difficult cases, we get results with SOT.
Yeah. Would you also comment, you still do all the other stuff though, right? Like we can't just do the kill pro, like just the SOT, right? We're doing full functional medicine workup, just like you mentioned, even with that.
Yeah, absolutely. So, this is what is he called? Beecham versus a beach camp or whatever, whoever he is versus Pasteur, right? I don't think it's an either or. It's, we got to kill the pathogen, but we got to make the patient more resilient. When I was a resident during the initial HIV crisis, when we didn't even know it was HIV. We just knew people were dying. We didn't figure it out. And so we'd admit 2 people to the ICU and we'd line them up and do all that kind of stuff. And they both do well. And we'd discharge them to the floor, and then one would crump and come right back, and the other one would go home. And it was the one with HIV that would come right back, because an incompetent immune system is never going to finish the last 10% of an infection. You need a competent immune system to really get rid of that last 10% of the infection. And so if we don't do all of that stuff to increase resilience in our patients, they're going to be the ones that you hear about all over the internet that Lyme is not curable, right? Because they just keep that last 10% keeps blooming and coming back and blooming and coming back. So you have to do this whole thing to really get people well. Yeah.
Very good.
Thank you for that.
So on that note as well, I'm talking about, having patients on a program for 18 months or more. If you want to address kind of that potential of resistance to antimicrobials, and if you're having to kind of switch those around.
Well, just like with TB, if you attack it from multiple different directions at once, it doesn't really have the opportunity to develop resistance, right? So you noticed I'm using Stevia and cryptolepis and phytobiotic and Biocidin. So, and Biocidin, by the way, is, 10 different herbs or more. And phytobiotic is 4, I think. So we're hitting this person with, 10 different antimicrobial herbs simultaneously. So the opportunity for developing resistance is not really great. So I'm not terribly worried about it. I don't normally switch up my antimicrobials. What I do, which some people would argue increases the risk of resistance, is to overcome part of the stealth pathology. I cycle those antimicrobials 6 weeks on and 2 weeks off. So 6 weeks on is a full kill cycle. And then we take them off so that, we've driven all of the bugs into their hiding places, whether they become cysts or they're intracellular or whatever they are, and they're quiescent. And I'm waiting 2 weeks for them to use their quorum sensing to sort of resuscitate themselves so we can hit them again. And we do that. And this is sort of my version of Dr. Berscano's, pulsing antibiotic idea. And we do that for the full 2 years, 6 on, 2 off, 6 on, 2 off for however long we treat. But I don't tend to see resistance. And Borrelia burgdorferi, oddly, isn't famous for developing genetic resistance. So I'm not terribly worried about the traditional antibiotic resistance ideas with bacteria.
Okay, so we're going to finish it up with this last question. I think that this is important just because we get this from a lot of providers as they are learning and kind of diving into the deep end of the Lyme pool. But where would you say were your best training options for things like herbal treatments for tick-borne illnesses? Because there's a lot of avenues people can go down.
Yeah. Well, and you know, I've been doing this so long that my sort of ideas predate all these training programs, and I never went into any of these training programs. Having said that, I think ILADS probably has, you know, the most scientifically rigorous ideas and conferences. So I would recommend the International Lyme and Associated Disease Society, ilads.org.
Yeah. So they have a foundational course that you can do virtually that you can sign up for. I think, I can't remember exactly how many modules, maybe like 8 or 10 modules. And then the conference is actually, at least the last 3 years that I've been, they are starting to add a lot more herbal treatment presentations. There's even, there was an entire day of all kind of naturopathic approaches to Lyme this last year, which was fascinating. All very well cited. Dr. Hinchy, who was here earlier, she spoke there in one of the weeks before us. And so I would 100% agree that ILADS is great, and they're really starting to add a lot more education around kind of like that herbal perspective as well.
Yeah.
Very good. Very good. Well, thank you, everyone. Sorry, somebody asked, can we spell it out? So ILADS, and it's in the chat right there. Elisa just kind of put it in the chat right there. ILADS.org.
Yeah.
All right. So thank you, everyone, for joining. Oh, go ahead.
I was just saying, International Lyme and Associated Disease Society.
Very good. Yes.
.org.
Awesome. Wonderful. Thank you so much for joining. And we'll see you all back here next week for our last session as we kind of wrap it up. Have a great day. Bye-bye.
Thank you very much.
Bye-bye.